Hi, welcome to another 4AC video. In this learning video, we want to look at the example 4.1, which is found in your lecture note in topic 4 on AC power. For the circuit given below, determine S, which is the apparent power, P, which is the average or effective power, Q, the reactive power, and FP, the power factor. So let's look at how we can answer this question. Okay, let's look at this. How do we answer this? Now, the first thing we must remember, S is for apparent power, which means the maximum power that we could extract from a system, where P is the average or effective power. That's the portion of the power that we actually get converted to another form. And we have the reactive power, which is retained in the inductors and the capacitors. And finally, we want to calculate the power factor. So one way to approach this is to look at the impedance, the total impedance of a circuit ZT. Now in this case, because this is a series circuit, all I need to do is to add the R. R is 6 ohms. Now this is inductor, so this is actually XL, and this is XC. Now we have learned in earlier chapters, XC is angle 90 degrees, so in the rectangular form we can write it as plus J7, whereas for a capacitor we write it as minus J15. So this gives us 6 minus J8 ohms. Okay, we can convert this to polar form. That will be 10 angle minus 53.13 degrees ohms. Right? So we need to calculate the current that is flowing into this circuit. So current given by Ohm's law is Vs upon Zt. Vs is 100 volt at an angle of 0 degrees, divide by 10 at an angle of minus 53.13 degrees. So that gives me 10 angle 53.13, sorry, it should be 3 degrees ampere. Now what does this mean? Current has a positive angle 53.13 compared to voltage, which is at 0. In other words, if I were to draw a phasor diagram, the voltage is pointing this way, V, but the current is ahead of it. So current is here at 53.13 degrees. So in this circuit, we know that the current leads the voltage. In other words, the effect of this whole thing is a capacitive circuit. So the next thing I want to calculate is the phase relationship between the voltage and the current. So phase relationship, D, is the initial phase of the voltage subtract the initial phase of the current, I, which is 0 minus 53.13 degrees. So that is negative 53.13 degrees. So power factor is just cos cosine of this negative number, which gives me a power factor of 0.6. We write 0.6, but we say it's leading because the current leads the voltage. Now, real power is given by the formula V times I cosine the theta angle. So what does that mean? That's equals to V, which is 100, multiplied by I, which we calculated is 10, multiplied by cosine of this angle, which is 0.6. So that gives me 600 watt. That's the effective power. Right, and finally the reactive power, we calculate reactive power as V IS sine theta, and that's equals to 100 times 10. Now sine theta, sine 53.13. Let's calculate that. That gives me 0.8, I think. 53.13 sine this number. Sorry, the other way around. Sine 53.13. 0.7999, so let's say it's 0.8. Okay, 0.8. That means gives me 800. Now instead of watt, we don't call it watt, we call it VAR for reactive. Okay, and finally apparent power is just VS, sorry, without the phasor, VS times IS. That's 100 times 10, so it's 1000 VA. Okay, this is making use of the magnitude, the impedance, and using the magnitude to calculate the average or effective power, the reactive power, and the apparent power and power factor. Can we think of an alternative solution? There is. Right? Now the alternative solution, we approach it from the same thing, that the total impedance is given by 6 minus J8 ohms. Now if I were to draw the diagram, the kind of phasor diagram of this is just R is equals to 6 ohms, and J, because it's negative, so this will be XC, is 8 ohms. Right, so the combination of these will give me my Z, which works out to be about 10, with an angle of 53.13 degrees. Now if we convert that to the power triangle, or kind of power phasor diagram, R, if I want to represent, I convert this to P, which can be calculated using I square R, which gives me 10 times 10, because current we have calculated is 10, so 10 times 10 is 100, 100 times 6, 600 watts. And similarly in this direction, we have the Q, in this case QC, because we know it's capacitive, and this is calculated as I square XC. So that will give me 10 times 10 times XC, which is 8, so that's 800 VAR. And finally, the apparent power S is just the square root of this thing. So here's the same angle, 51.13 degrees. So this is just the square root of p square plus q square. So equals to 600 square plus 800 square. That gives me 1000 VA. Power factor is the cosine of the angle by this, formed by this, so it's 53.13 degrees. That gives me 0.6. Okay, we call this again same thing, is the leading power factor. So this is the alternative solution compared to the original one. Okay, so this is question 4.1. I hope you learned something here. Bye bye.